All right, everybody, today our lesson is 1.10. We are focusing on solving and graphing compound inequalities. Our warm-up says to name 3 solutions to this compound inequality. It says that -4 is less than or equal to x, which is less than 5. They must be whole numbers, they must be integers, they must be rational. So we're talking about any whole numbers in between -4 and 5. Well, we do have that equal to symbol, so that does show me that I could have -4 be a solution. I could have -3, -2, -1, 0, right? We could go on and on and on up to 4. We can't have 5 as a solution because it's not equal to, right? So we could put any numbers in between those two. To graph this, we're going to graph just like normal, except our graph is going to stop. It's not going to continue on like in with our other problems. So let's start with graphing -4 is less than or equal to x. We could also say x is greater than or equal to -4, right? So I did say that -4 could be a solution because it is equal to. So on that -4, I'm going to put a closed circle. And if I'm showing that x is greater, I'm going to draw my arrow to the right where the numbers are getting larger. So I'm going to shade to the right of the -4. Like I said, I'm not going to continue my graph on and on forever because it does have to stop with that 5, right? It's not equal to 5. It has to be less than 5. So I'm then going to take an open circle on the 5 because it's not equal to. And how I would show that x is less than 5, I would shade to the left, right? So looking at this graph, I would kind of combine and shade everything in the middle to show that the numbers -4, -3, -2, -1, 0, 1, 2, 3, 4 could all work in this compound inequality. So when we talk about compound inequalities, these are inequalities that contain at least 2, and they're separated by an and or an or. So our last example, this is an and. X is greater than -4 and less than 5. It's combined together. When we shade, it overlaps. An or would be that the solution is true for one or the other. So x could be greater than -5 or less than -4. In a case like that, they would be shaded in opposite directions. So your number line might look something like you would have maybe a closed circle here, and then everything shaded over here, and then an open circle here, and everything shaded over here. So they would be going in opposite directions. It would be either true for this one or true for that one. And we'll show some more examples of what that looks like, but that's just a quick one. So our first problem, we do have to solve for x. We do want to isolate that, and we can do that in 2 ways. The first way is that you could separate this into 2 separate inequalities. So you would start at the left. Your -7 is less than or equal to x minus 8, and you would stop at that next inequality symbol. You could rewrite that out, and you could solve that as so. You could also go to where your middle is, x minus 8, and then go to the end, and you would separate the second inequality. So you'd have x minus 8 is less than or equal to -5. So you could take away 2 inequalities and you could bring them back together. The other way to do that, is to just do whatever you do to the x to get it alone. Make sure you do that to all of these sides. So for example, x minus 8. If I want to get rid of that -8 and get x alone, I'm going to add it, right? So if I were to add 8 to get rid of it, I would have to add 8 to the 5. I would also have to add 8 to the -7. So whatever I do to the middle, I have to do to the left of the inequality and the right of the inequality. So -7 plus 8 would be 1. I would have 1 is less than or equal to x. We got it alone, which would be less than or equal to 5 plus 8 is 13. So that's one way to solve it. The other way to solve it, like I said, is I could separate it. -7 is less than or equal to x minus 8. And then I would add 8, and I would still get 1 is less than or equal to x. Then I would do the other one. I would do x minus 8 is less than or equal to 5, and I would add the 8, and I would get 13. So either way you do it, if you want to separate them, you can. If you want to do it all at once, you can as well. It's just kind of a preference thing of how you would like to do it. So now that I have 1 is less than or equal to x, which is less than or equal to 13, I'm going to go ahead and draw my number line. I'm going to put 1 in there, and then I'll put 13. And we could put any number in the middle. We could say like 7. To graph this, I'm going to have closed circles on both numbers because they are equal to. And again, the x falls in the middle. It's greater than 1, so I go this way. It's less than 13, I go this way. So I shade everything in between. So x is greater than 1 and less than 13. Equal to both. So 1 and 13 are both solutions. Number 2, again, whatever I do to the middle to try to isolate x, I have to do to all 3 sides. So I'm going to start by dividing by 3 to get rid of that 3 in the middle. So this would give me 5 is less than or equal to x minus 1, which is less than 8. And from there, to isolate the x, I would add 1. So I would get 6 is less than or equal to x, which is less than 9. And we would start our number line. So we could put 6, we could say 7, 9. We are going to have a closed circle on the 6 because it is equal to, and we are going to have an open circle on the 9, and we are going to shade in between. So here's an example of an or. I have 5x plus 6 is less than or equal to negative 9, or 2x minus 8 is greater than 12. And we're going to solve these completely separate. So I'm going to start with 5x plus 6 is less than or equal to negative 9. My first step to getting x alone would be subtract 6 from both sides. I would then have 5x is less than or equal to negative 15. And I would divide by 5 to get x alone. So I have x is less than or equal to negative 3. So that's 1. Then I have my or, right? And on the other side of the or, I have 2x minus 8 is greater than 12. My first step would be add 8. So now I have 2x is greater than 20. And I would then divide by 2. So I have x is greater than 10. So I have x is less than or equal to negative 3, or x is greater than 10. So let's draw our number line. We must have negative 3 on there, and we can have 10. For our x is less than or equal to negative 3, we're going to have a closed circle. X is less than 3, so I'm going to have my shading going to the left where the numbers are smaller. My second inequality says x is greater than 10, so I'm going to have an open circle. It's not equal to. And this one's going to go to the right because it is greater, so where the numbers are larger. So that is what an or would look like. So it cannot be an and because it doesn't make both of the statements true, right? One of the solutions for x is less than or equal to negative 3 could be negative 10. Negative 10, however, is not greater than 10, right? So it wouldn't fit both inequalities. It would only fit one or the other. Let's do another. And so let's start by subtracting 1 to try to get our x alone. This will give us 15 minus 1, so 14 is less than negative 7x, which is going to be less than 15 minus 1 is 49. Okay, so we do have to divide by a negative here. What's our rule when we divide by a negative? We have to flip our signs, right? So we're going to do that. We're going to flip every single sign because I'm dividing each number by that negative 7. So 14 divided by negative 7 is going to give us negative 2. I have to make sure I flip my sign. And we're going to have x alone. Again, make sure to flip our sign because 49 divided by negative 7 will give us negative 7. So now we have negative 2 is greater than x, which is greater than negative 7. Let's go ahead and draw our number line. Negative 7 would be to the left of negative 2, right, because it's actually smaller. I would have open circles on both. if I were to read this, this would be -2 is greater than x, which is greater than -7. So -2 is bigger than x, or x is less than -2, so I would go this way. But x is greater than -7, so I would show you this way. Know that everything in the middle could be a solution for this problem. We could rewrite it left to right so that we could read it as -7 is less than x, which is less than -2. Sometimes that helps us to graph. All right, we have one more or. I believe this is our, no, we have two more ors. Okay, so we have 4x plus 5 is less than 3. Like I said, we're going to solve these completely separate and just do them one by one. So let's start by subtracting 5. We will have 4x is less than -2, and then we'll divide by 4 and have x is less than -1/2. That's our first. Again, this is separated by the or. And on the other side, we can start by adding 2 so that we have 3x is greater than or equal to 3. And then we will divide by 3 to have x is greater than or equal to 1. So we have x is less than -1/2 or x is greater than 1. Let's go ahead, draw our number line. We're going to have -1/2. We can put 0 in the middle and 1. Our -1/2 is going to be an open circle. X is less than -1/2, so the numbers would be to the left. X is greater than or equal to 1, we would have our closed circle. And since x is greater than, we would shade to the right. So we just solve them completely separate and graph them on the same number line. One more or. All right, so this one has multiple variables on both sides. So let's get started on that. I like to keep my variables positive. It's just my preference. So I'm going to start, I'm going to try to get my x over to this side. So I'm going to start by subtracting 5x from both sides. This gives me x plus 3 is less than 1. From there, I'm going to subtract 2 to have x is less than -1. So that would be my first inequality. Or I would have 1/3 x minus 4 is greater than or equal to -2. Now, I prefer to get rid of fractions before I do anything else. So I'm going to start by multiplying that entire inequality by 3, just like we do with equations. I'm just going to multiply everything in the equation by 3. So 3 times 1/3 would just be 1, or just 1x. 3 times -4 would be -12. And 3 times -2 would be -6. So we would have x minus 12 is greater than or equal to -6. And I would solve that by adding 12 to get x is greater than or equal to 6. -6 plus 12 would give us 6. So x is less than -1, or x is greater than or equal to 6. Let's start with our number line. We can have -1 and 6. We could put 0 in the middle. All right, so x is less than -1. We have an open circle, shade to the left. X is greater than or equal to 6. We have a closed circle. We shade to the right. And that is it for our compound inequalities. So you can always decide if this is going to be an and or an or. Don't forget to graph your solutions on the number line, especially if you're not given the number line. You just draw it just like I did. Check your solutions, make sure that they should have like their closed circles or the open circles. Always double check that work. When you're done graphing, go back and check your graph and make sure you shaded correctly. Remember, the ors should go to opposite directions. The ands are on top of each other. For and compound inequalities, always write your final answer as a combined inequality. So always put it back together if you do solve it separately. Make sure if you have any questions to reach out to your teacher and get those answered. Have a great rest of your day.